Do it again, Jib? Just kidding. All right, so here we go. Get rid of this one. Pull him up. And oops. Wait a minute. Wait a minute. Wait. Let me think. Where's his video? It's just PowerPoint, isn't it? Wait a minute. I did a separate video in 2 parts. Oh, okay. All right, he did 2 parts. Didn't know that. Dumb today. Wait a minute. Okay. Have you seen Alan? You talked to him at all in person, or I mean, Zoom or anything? Okay. Oh, say it. I can't hear you.
He was in some of the Zooms on like the practice.
Oh, he was. Okay. All right. Ready? There you go.
Hey everyone, this is Alan. I'm going to talk about condensation polymers today. And this PowerPoint is used as a sort of virtual handout. So what is condensation polymers? Condensation polymers are any kind of polymers
I thought he was doing the other one.
condensation reaction where molecules join together, losing small molecules as byproducts such as water or methanol. According to the packet, when the joining of monomer units is accompanied by the loss of a small molecule such as water or hydrochloric acid, the condensation polymer formed. Monomer mentioned above is a molecule that can react together with other monomer molecules to form a larger molecule chain. No, a larger polymer chain or 3-dimensional network in a process called polymerization. And any monomer capable of becoming part of a condensation polymer must have a functional group on each end. One functional group of the first monomer links up with one functional group of the other monomer. Then the functional group is free to link up with functional groups of a third monomer and then fourth, etc. This is how a polymer chain forms. Let's go to polycondensation. Condensation polymerization is a form of step growth polymerization. Linear polymers are produced from bifunctional monomers, which is compounds with 2 reactive end groups. Example of a condensation polymer is nylon, which is created in 1937 by DuPont chemist Wallace Carothers.
That's what you said?
This polymer is classified as a copolymer since it is composed of 2 different monomers, including adipic acid and hexamethylenidiamine. Adipic acid contains 2 reactive and
Okay, so I'm not sure you mentioned it. Did you say what copolymer? Did you say that word?
Maybe, I don't remember.
So you can have a polymer made of the same monomer over and over and over and over and over. See that? But what if you have a polymer that's made of one monomer and a different kind of monomer? Then what's it called? Copolymer. Okay. Did you see that when you were reading? Do you remember reading that? That's what a copolymer is.
end groups, which are all carboxyl groups, and hexamethylenidiamine contains 2 reactive end groups, which are all amine groups. It looks at the packet. One end of an adipic acid molecule here, and one end of a hexamethylene molecule here. It can be made to react with each other, splitting off a water molecule in the process. That's a water molecule. After 2 monomers have joined to form this, the reactive ends still remain for further reactions, which leads to a growing polymer chain. Finally, looks like this. And let's go to the concept chat. So it's 6-aminohexanoic acid suitable monomer for forming a condensation polymer? The answer is yes. One of the simplest of the condensation polymers is a type of nylon called nylon 6. It is formed from an amino acid, 6-aminohexanoic acid that has 6 carbon atoms in it, hence the name nylon 6. All amino acids molecules have an amine groups, NH2 at one end and carboxylic acid, COOH group at the other end. Polymer forms when a hydrogen atom from the amine end of one molecule and an oxygen-hydrogen group OH from the carboxylic acid end of a second molecule split off and form a water molecule. The monomers join together as a new chemical bond forms between the nitrogen and carbon atoms. This new bond is called an amide linkage. Polymers formed by this kind of condensation reaction are referred to as polyamides. The new molecule, just like each of the monomers from which it formed, also has an amine group at one end that can add to the carboxylic acid group of another monomer, and it has a carboxylic acid group at the other end that can add to the amine end of another monomer. The chain can continue to grow and grow and grow and form very large polymers. Each time a monomer is added to the chain, a small molecule byproduct of water is also formed.
Okay. Is this the second one? Yep.
Part 2 of the video. Let's talk about PET. It's a very widely used material in our daily life. It is used in fiber of clothing, containers for liquids and foods, and thermoforming for manufacturing, and in combination with glass fiber for engineering resins. And in our packet, PET is formed by terephthalic acid and ethylene glycol, of course through polymerization. And fruit also works. Monomer that contain 3 reactive functional groups, like this, can also form polymer chains. These chains become interlocked in a rigid 3-dimensional network that lends considerable strength and durability to the polymer. Once formed, these condensation polymers cannot be remolded or reshaped, which makes them hard set or thermoset polymers. And thermoset means like material which remain in a permanent solid state after being cured one time. An example of the thermoset polymer is formed from the reaction of formaldehyde with melamine. By the way, formaldehyde itself is kind of harmful to human body. When the air is filled with a certain concentration of formaldehyde gas, we will feel very, very uncomfortable. The synthetic polymers industry has grown remarkably over the past 50 years. Annual production of polymers in the United States alone has grown from 3 billion pounds in 1950 to 100 billion pounds in 2000. Today, it is a challenge to find any consumer items that does not contain that plastic of one to another. In the future, there will be new kinds of polymers having a wide range of remarkable properties. Some polymers conduct electricity, some emit light, and some replace body parts. Some are stronger but much lighter than steel, blah blah blah. Polymers hold a clear promise for the future. And there's something interesting. Natural polymers. Nature produces a variety of polymers. They are built by an organism usually, Examples included silk, natural rubber, starch, chitin, and proteins. And this is a picture of natural rubber. And this is the end of the presentation. Thank you, everyone.
Okay, nice to see him again. Okay, let me. All right, you guys are quiet. Anyway, that's my fault because I think I signed in with him before I signed anyone here. So I thought we were gonna do both of them. So now it leaves out one of them. I need to do just a little bit of filling in here. All right. Let's take a look at this. Let's take a look at this. We actually did this when we were doing a little bit of model building, and you've already read this. It's your responsibility to have read this whole packet, right? Is everybody working on the questions? They're pretty much done by now, you think? Okay. And we did this in the model building. What if I started with ethene, also known as ethylene, ethene. What if I wanted to combine those? How would I do that? Now, if condensation polymerization, that's what Jeb was talking about, Alan, it always means you have a loss of small molecules like HOH, HCl. But what about addition polymerization? What's different about that? Well, no atoms are lost. Very, very good. So that's one of the questions they ask on the test. But there's by breaking the double bond, you can actually have these things polymerize with each other and make long, long, long chains like this. Okay, now these you don't have to know these, but these are different types of plastic. And the next time you get ready to throw something away, you might want to look at it to see if it has one of these symbols on it. And if it has one of these symbols on it, that means it can be recycled. Everybody got that? So even little tiny plastic things will have that little symbol on it telling you that, hey, yeah, it can be recycled, like that. All right, have you heard of these things before? Have you heard of polyethylene? Okay, polystyrene. What's polystyrene? Anybody know what that is? You know what styrofoam cups are made of? Styrofoam cups are made of polystyrene. How about rubber? Polyethylene, polyvinyl chloride. You've heard of that? What's PVC pipes? You ever seen pipes made out of PVC? That's polyvinyl chloride. What else have you heard of? Plexiglass, Teflon. Here's Teflon. Saran. See that saran? That's like saran wrap. All right. Okay, here's some other one. Okay. It says here nearly 12 million tons of polyethylene are made annually in the U.S. That's about 90 pounds per citizen. Can you imagine that? That 90 pounds, every one of you consumes about 90 pounds of plastic, polyethylene plastic in the United States. It's an unsaturated, let's see, you take ethylene and unsaturate it and make it all into a polymer like that. One other question I know is on the test, because again, I didn't write this part of the test, but one of them they talk about these. Do you see those two drawings? Does that mean anything to you when you were reading it? There are some plastics that when you build them have all these branches and they're like this. And then other ones are like this, and they kind of line up each other. So what do you think? What do you think the difference would be here? What is L? What is LDPE? LDPE, and what is this one called? HDPE. Do you remember reading that at all? If they're lined up, you can pack a lot of them in a little bit of space. So what is that H? What is it?
High density.
High density polyethylene. You get that?
Like water and ice.
Like what?
Well, because when ice
Okay.
is frozen, they're spread apart farther than.
Everybody say, all right. And what about the other one?
Low density.
Low density polyethylene. Okay, so that, I know that's in there about that. And let's see, what else is there? This is the same thing. In this case, we're taking, what would be the name of this monomer? What would be the name of that monomer? Uh-oh, that's a problem. It's got 3 carbons, so it's prop. It's got a double bond, that's ene. So isn't it propene? Or propylene, same thing? Okay, so we got propene or propylene, and you're trying to break the double bond, and then you can make a monomer, polymer that would look like that. This happens to be polystyrene, that's styrofoam. So if you want to make styrofoam, you have that. And what's the other one they notice? PVC. And one thing I thought was interesting about, have you ever heard of, this is the saran wrap here. Look right here, and what's different about that one? What's in there that you haven't seen before? And chloride ions are, the chloride atoms here, they're a lot bigger than the hydrogens. And the theory is that this is what gives that clinging ability. You ever take a bowl and take a plastic wrap and you wrap it over there and it clings to it? They think that is it. It's the interaction between chlorine and the glass molecules that make it clingy. And of course, they sell a huge amount of plastic wrap in the United States. Okay. All right. What else is on here? And that's my fault for assigning the same thing to 2 people. And we talked about Teflon before. That was about it. All right. And one more thing, and then I'll stop here. We had done this one other day. I do have, let me tell you what the test looks like. I really do, let's assume that they're completely wrong and we come to school tomorrow. Then you would have your test tomorrow, okay? But it would be on Thursdays, you come after lunch. My opinion would be, if you want to relax a little bit more, you could come in during part of your lunch and get started early. You can finish the test in one period, but you have to kind of know what you're doing. You have to kind of get to it. You get it? So I would like to offer that to you, that you can give up to 30 minutes extra. If you wanted to come in, you could even come in, eat your lunch. I just don't want, I'm afraid if you're under too much pressure, that you'll have a little trouble finishing. But so here's what it looks like. About, I don't know, maybe, I don't know the exact number, 2/3 of the test would be from the packet. So that's where I just go through the packet tonight, and everything I highlighted, I kind of look at those kind of things, all right? You might even remember, say, oh, I remember Carson and them, I remember they did that stuff with alcohol. I remember that one. Or I remember Jeb, he did that condensate. See, you might be able to remember who did what to help you remember the memory tricks. Who had aldehydes? What was your memory? Oh, that was Al Powell, wasn't it? What was it again? It was
It looks like that.
okay, I never heard that one before. And how do they remember what an aldehyde group is in?
It has the carbonyl and then that,
Does it have a carbonyl in it?
yes, carbonyl.
Okay, that's a C double bond O, isn't it? And what else does it have? Okay, so it's C double bond O and then H. Okay, but what if you were an organic acid? You'd be C double bond O. What? C double bond O. OH. Is that right? All right. Another thing we did. So about 2/3 of it will be from the packet, and some of them are picky. Like, do you remember Alex them telling you that the #1 alcohol made in the United States by far is, if you had to take a guess, which one would it be? Which one? Oh, that's a good guess. Okay, I would have said most of you thought it was ethanol because people drink so much, but it was actually methanol, wasn't it? By far. Okay. So yes, there are questions about the packet, and if you've read it and done the questions, you should be able to pick up on them like that. All right, now, so if you do pretty well on those are multiple choice. Those are multiple choice questions. They go a little faster, don't they? Now, the second part is almost identical to the quiz. They're not identical, but the same type of questions, okay? So if I asked you to do a carbon backbone there, I would ask you to do that. If I said, hey, draw some isomers of that, you draw the isomers with backbone. If I said do a stick structure, you do that. And I have two of these. I have two of these on there, okay? Now we did a couple of these, one or two? One. Let's pretend that I ask you to do this one. All right, what do you think? What would the molecular formula for that one be? All right, how many carbons do you think this guy has? So let's go ahead and draw it. Matter of fact, this is what companies made. This is artificial butter. This is what makes things taste like butter popcorn, microwave popcorn, or cookies might have a butter flavor. And instead of going and getting cows and milk and all that kind of stuff, they can artificially make this chemical, and it will make things taste like butter. So, how many carbons? Tim?
I just wanted to ask how chemically similar to water is the...
Say it one more time.
How similar
Oh.
chemically is
I would have to look that up because butter from a cow's milk, I would have to look to see, are there other things besides just the butter? That's a good question. I actually don't know that. Would there be some other things in cow's butter that are slightly different? But for humans, if I put that in cookies, you say, buttery. Or popcorn, buttery. So I think there'd have to be something different, but this is one of the chemicals that would be in there. But there might be a couple other things that I don't know about. That's a great question. All right, how many carbons? All right. So, all right. Now, how many oxygens? That's easy. Now, here's the one you got to be careful about. How many hydrogens? How many hydrogens going to attach to this guy? 1, 2, 3. He already has one bond, right? So he has 3 more, right? What about this guy? 1, 2, 3, 4. No hydrogens for you. No hydrogens for you. What do you think? Can you do that? So anyway, I picked a couple of these, and it says, give the molecular formula. Just take your time. Just take your time and do that, okay? All right. What else? Okay, so let's talk about the weather a little bit. Well, let's say if nothing happens, you just go ahead and have the test, and if you want to come in at lunch, you can do that. What if they had a 2-hour delay? And a lot of times when they do a 2-hour delay, and Mr. Silling's not even on campus, but I think he'll make a decision. If they had a 2-hour delay, they'd probably just get rid of 2 of the first 2 periods tomorrow. You see that? And then that would still make you could come in at lunch and take your test. What if they have no school at all? Well, then I hate it, but I'd have to wait till Monday to give the test. Now, if I give it on Monday, you take the class right before lunch. So I would certainly be willing to, if you wanted to stay a little, and I hate it because I know you like going out to lunch. I know that. But if you wanted to take the time, I would be here and let you finish it during lunch if you wanted to. Yes?
So what if they don't just scrap the first 2 classes? Like, what if they modify the schedule so we have each class
That's a good question.
What have done in the past with 2-hour delays?
You know, Mr. Greer would have done that for sure. He would have modified everybody. And Mr. Schilling in the past has done it where he just cuts them out. He just, but if he were to modify all the classes, what I don't know. That's a great question. Oh man. If it's too short, I might just have to wait till Monday. And I hate that. I hate having a test on Monday. But I don't want you to see part of the test and then have 3 more days. I don't like that idea. It's tempting. It's way too tempting to look up things, stuff like that.
If it's a 2-hour delay, would every class be 45 minutes?
Well, and yeah, I could be I guess I could say, too bad, 45 minutes plus all of lunch. That's enough. I could do that, but that does force you to use all of your lunch, and then everybody had to kind of agree to that. I don't think it's fair to, I can't do it. I have, That's a great question. I wish I had the answer to that one right now.
Should we just-
Sorry. You know, what I could do, I hate to give you another study day. I don't know what you do with another study day, but, I mean, I think that if it's down to 45 or 40 minutes, I think I would just give you a study day, and just, would that make you feel better?
Yeah, thank you.
I like working with you. You work so hard. You do. You work hard. So I'm willing to work with you. So if we just have a delay, have normal school, we want to have the test tomorrow. Is that okay? So take yourself home. Act like you're taking it tomorrow. If somehow I'm not even sure when I'm going to know. When am I going to know what the schedule is?
They always decide at like 5 in the morning.
It's possible he would do it this afternoon. If he looked at the weather and said, "Oh yeah, it's coming," he might. I think they if they're talking about a half an inch, if it's freezing rain, that's bad, because it just keeps collecting more and more and freezing and making the trees heavier and heavier. If it's sleet, that's good. Well, it's not good, but sleet falls all the way, hits the branches and falls to the ground. So you don't get the weight. Most of the time, you don't get the weight on the trees with sleet. It's the freezing rain that they're talking about a possibility of half an inch. We had a third of an inch on the last one. No, of freezing rain. If we were to get a half an inch of freezing rain on trees and things, that could be bad. And you're not going anywhere. You wouldn't be going anywhere in your car probably. Now it'll take a while. It's going to get in the 40s today. It would take a while before the roads would freeze over. But once they did, once all the heat from the earth has melted the original frozen water, then it would start freezing. So anyway,
When would that really happen?
after midnight.
Okay.
So it doesn't even start till after midnight. So anyway, I just wonder if they're wrong though about the temperature. Are we on this side of the cold air, or are we on this side?
What did they say from the last time when Did they say what they're calling now?
They're more likely to be wrong about snow than this. This I think they might be hitting this one. So what is it?
That makes sense because this is.
So okay, hey, I don't have anything for you. If you want to just, oh wait a minute.